fine. Thank you very much indeed, SEGH headquarters, telling us that it's going to be recorded, which is great because it means that for the people who did get the time wrong, they can come and watch it on the recording later on the website. So without further ado, go on.
And Andrew won't have to do it again in an hour.
Absolutely.
The new and improved version.
With all the mistakes skipped over, yeah.
We'll let you edit it out afterwards. Okay, so without further ado, I'm going to hand over to Andrew for the latest in this series of Fellows Talks for SEGH, which is absolutely fantastic. And I really say thank you to you for producing and delivering this. Interesting title, so I'm really looking forward to hearing what's in there. I'm going to have to read the second bit. First bit is Tall Tales from a Lopsided Geochemist, and it follows behind with navigating interdisciplinary research in an environmental geochemistry and health. So Andrew, all yours, please.
Thanks a lot, Gillian, and thanks everyone for coming along. Hopefully this will work. If someone can say yay or nay, you can see my screen.
Yes, can see it, thank you.
Brilliant. Okay, so thanks a lot. And I guess I've been pestering a lot of people to join in with this, and it's my turn. So what I wanted to do was really sort of take a step back and I guess offer some perspective from quite a wide-ranging journey around the sort of geochemistry and health arena, and as with the sort of instruction that we developed for these fellowship presentations, think a little bit about our own journey and what we would perhaps offer as points of advice. Certainly in terms of my own experience, the range of interactions I've had, and obviously some tall tales that come from some of the interesting projects that have stimulated my continued interest and enjoyment in the environmental geochemistry community. So the title is a little bit of a funny mouthful. Hopefully it'll become apparent, and certainly when we talk about tall tales, I guess sort of definition is something that's a little bit more embellished than would be true in reality, and I guess that's what most of our presentations are. They're the tall tales that we present to show what we've achieved, and very often it misses some of the truth behind it in terms of the disasters, the complications, and the challenges. So perhaps the tall tales will have a little bit of reality in them as I go through. The lopsided bit I'll come to at the end, and that's really something that was inspirational, motivational for me in my career. And along the way, there are pictures of places that I've encountered, except the one in front center here on this title slide, and that's stolen from an applied geochemistry special issue from many years ago that I've cut out and scanned, and that just reminds us how fundamental our science is, and that is a picture of Victor Maurice Goldschmidt having a conversation with Albert Einstein on the shores of a fjord in Norway. So if we need to think in terms of fundamentality of our work, this is a point to bring us home. Beside trees that are devastated by acid rain, waste dumps of petroleum hydrocarbon, and the wide open plains of Africa that support a lot of subsistence farmers. So a very diverse set of conditions. So me as an environmental geochemist, as my colleagues have already outlined their own little history, the collage of pictures on the right hand side just reflecting some of the sort of interactions from recent past, but I started off along this journey as a young PhD student, doing a little bit of postdoc work in field of environmental radioactivity, and then landed my first temporary academic role in a Department of Chemistry and Chemical Engineering in what was then Paisley College of Technology and now is the University of the West of Scotland. And being the sort of only geochemist in the whole organisation was really quite a challenge in terms of trying to find my own focus and my own way forward. I took a job as a lecturer in organic chemistry, but very much had the sort of desire and the background in terms of the geochemistry of our surrounding environment. And joining SEGH very early on in that place on that point was very important for me as an early career researcher, although the levels of support were negligible in terms of my own career path. So developing ideas around geochemistry and health, waste and resource management, but also getting involved very much with some of the regulatory challenges, particularly getting involved in early air quality monitoring campaigns with the local authority, just to try to establish some systems that were able to feed back in terms of trying to control exposure of the public to priority pollutants. So through my career as a professor from 2002, having roles as head of department, assistant dean, and finally, more recent years, a long-standing commitment to work in Hunan province in central South China through a number of fellowships, both my exposure to potentially toxic elements and also chilies in the variety of very hot spicy dishes from that region was really important part of the sort of more recent part of my journey. So current research focuses on a range of areas in collaboration with a number of colleagues in antimicrobial resistance, resource exploitation and impact on the environment. So a whole range of waste, metal, processing and exploration challenges for new energy sources, in particular looking at locations where food chain has been compromised and the exposure of individuals is really, or can be really quite severe, through to more general environmental situations such as looking at environmental quality in urban ecosystems, both from soil and air and water. And also getting involved collaboratively with colleagues very interested in the challenges of sort of society across the planet, finding that I'm invited in to describe environmental conditions where populations are forced to move and exist within, and that sort of collaboration has really been very interesting in terms of informal workers and transient communities in the environment. And so when you start to tot up where you engage with things like the UN SDGs, which is very important for current research perspectives, you find that the key words that are summarized there on the right hand side sort of populate with a whole range of well-known topics of toxicity and waste and pollution, but also in terms of life cycle assessment, social determinants of disease, food security and supply, and management of agricultural systems, all which seem to have engaged with the whole sort of underpinning environmental geochemistry that I'm trying to address in the research projects. And as far as SEGH is concerned, I guess also want to sort of reflect on the sort of journey through the sort of membership that I've had with SEGH, joining in 1992, hosting an event conference in 2005 after being press ganged at a bar in Brighton by two senior members of the society to say, it'd be very nice to visit Scotland, would you like to run the event next year? And having a role as European chair and then president in 2013 to 15, and embracing the idea of the fellowship scheme 2019. So hopefully continuing to engage and contribute to the future of SEGH as we move forward. Again, a few snapshots. Apologies for those who are here that I had pictures of that I missed, but I just put a few examples on the screen there, just to give a flavour of my engagement and my experiences with the wider SEGH community. And I guess at the top there's a conversation that Alex and I had a very, very, very long time ago in Bratislava that continues, which again is one of the highlights of being part of SEGH. And so what have I gained from SEGH? What do people gain from SEGH, and what do our members hopefully welcome from that interaction? Well, I've tried to just summarize it in terms of some of the key messages. I think it's an outstanding international inclusive family, and I mean family in terms of the warmth and empathy that members have had, both new students as well as some of the sort of long-serving participants in the community. The science and questions around our meetings are always brilliant, always diverse. The meetings themselves and the events that individuals and groups organise have without doubt been outstanding. Wonderful representation of the local cultures, regional flavours of the food and the environments, the history and the culture really are standout things, and one of the big motivators for getting together and learning new things about your subject. As a early career scientist, certainly using SEGH as a platform to try to develop collaborations, and looking back on it from where I am now in terms of the progress of my own students and colleagues, very nurturing environment to develop. And I guess one of the other elements of it is that there's a group of peers that you can access, whether it's to support you in various things within your own institution, through to personal development and looking for the odd PhD examiner as you go through. So again, the benefit of the vibrancy of this organisation is really really outstanding, and one of the many reasons that I've continued to engage and support as much as I can. So that's a bit about the journey here and the background to my engagement with it. And I suppose it leads on to really what I wanted to talk about, and that is the sort of challenge that faces us now. And I think just looking back at my own journey and looking around me at where the pressures are, and I guess it's also been boosted by what we've just lived through and are living through in terms of global pandemics, making us change our behaviours in such a rapid manner, but also the challenges of climate change, economic pressures, and the whole diverse landscape that we live in at the moment. And from a scientific perspective, gives us a real challenge to try to bring our knowledge and our skills to try to make the world better and to learn more about it. And so, wicked problems are terms that are often used, coined, I guess, in social sciences, but from an environmental perspective, looking at, if you like, the unsolvable dilemmas we find ourselves in climate change and the loss of ice caps, the increase in extreme events in forest fires, and challenges to the hydrological cycle, and I guess the focus there being that we need to try to understand the complexity and conflicts within the system that we're focusing on, or need to focus on, and for that we need the skills and we need the perspective of multiple disciplines. And I guess in terms of environmental geochemistry and health, we've always been in that position, and moving forward, the sort of opportunities that arise or are opening up for colleagues, and particularly the sort of early career researchers, are to try to find their place in that environment where skill sets are increasingly in demand, but the applications are increasingly more diverse. And that is being recognised in some of the major sort of funding initiatives, see both in the UK, across Europe, and internationally. The opportunities then that the next generation, if you like, of environmental geochemistry and health practitioners will find themselves. And I guess to sort of emphasize that complexity, this is a fairly old diagram that it essentially is a map of disciplines that are associated with environmental sciences. And if you look just into the sort of slightly left of center, you can find the word geochemistry, but when you try and find the word health, you have to cross many mountains of other disciplines to the southeast of that map, and so linkages and subject areas that we come across in between are all sort of fairly familiar to our community, but each of them is defined quite discreetly in terms of a subject area, and I guess that is one of the sort of first things to think about is, you know, what are you, who are you, and where do your skill sets lie within this landscape? And I guess if we took a poll of even colleagues around the screen in terms of what you think you are in terms of your discipline, okay, we're all part of SEGH, but are we more geological, or are we more health, or do we have a sort of a technological perspective in terms of tools and materials that address some of the topics? And that's nothing to be ashamed of. It's something to be celebrated, but it also raises a difficulty in terms of that navigation across that landscape. And if we are able to navigate, then I guess the challenge then is that we have opportunities to bring teams together that have a longer reach, if you like. They need to be able to come together and share a common understanding of where the opportunities lie in terms of addressing some of the sustainable development goals that drive a lot of the work that we do now and into the future. There are challenges in terms of maintaining the depth of the subject and who you are, and how you then work across disciplines with others. From a more environmental science perspective, from a SEGH perspective, I guess we deal very much with Earth systems and thinking in terms of resource exploitation, but also ecosystem services that might be challenged and compromised. So even within the Earth systems, we're going very much from the physical and the geological through to the biological and ecological side of things, including the little lumps of carbon called human beings that bounce around across the surface of the Earth in really quite random patterns sometimes. And that knowledge is then fundamental to some of the big questions, the wicked problems of the current situation that we have, that we can contribute to. So challenges of food and water security are becoming more and more acute, both from a climate change perspective, but also from a political perspective. We've seen the shock from COVID and the impact on supply chains and resources being in the wrong place for where they're needed, and also the impacts of conflict as well, currently disrupting globally our living system. I would say at one point on the horizon, but I don't think it's on the horizon anymore. And the next big challenge, or the challenge that's even bigger than COVID, is antimicrobial resistance and the sort of impact of the Earth system in terms of how it engages with the challenges we have to maintain health and well-being in a planetary system that is feeding itself substances that reduce its resilience, and how governments can then come together on a global basis to try to address these challenges. And the One Health initiative is part of that. And as a result, we need to ensure that we deal with these challenges in a multidisciplinary and interdisciplinary approach. The language is quite difficult. Multidisciplinary, interdisciplinary, and even transdisciplinary are sort of subtle variations but of a term, but make very big differences in terms of how you address problems. So if you have groups of particular disciplines working on one particular problem, or you find groups that work between their own disciplines, or use their knowledge to look at the space between their disciplines and generate new learning, then we do benefit from it. And the sort of more esoterical issues of transdisciplinary work is very much taking that into an area of identifying new concepts to take forward. But in terms of a practical perspective, a couple of case studies, a couple of tall tales, just to perhaps illustrate some of the challenges. One project we looked at was the sort of negative feedback of agroforestry on a really important ecosystem within the Mediterranean region. That's the Quercus suber forests in southern France and Spain, Portugal, and across into North Africa. The presence of cork taint is has been the death of the cork stopper for the wine industry, and the rise of the screw cap, and that is recognized to be down to the contamination of the cork bark as it's being harvested by persistent organic pollutants, in particular chlorinated pollutants that then are biodegraded to give the taint to spoil up to 20% of annual wine production. And the result of our work with a NATO-funded Science for Peace program was to try to look at where that leakage is, if you like, into the cork production process, where pops are banned within the main EU region, but cork bark is imported from outside in areas that don't manage it in a particularly elegant manner, using sort of the interventions of pesticides and poor management practices, which then have a knock-on effect in terms of supplying contaminated material into the system. And I guess the sort of interdisciplinary side of that was very much microbiologists, soil scientists, biotechnologists coming together to deal with a problem that is a social challenge in terms of cork production in regions that benefited economically very significantly from adopting it, but where the quality control was very poorly applied, resulting in a negative impact on the whole ecosystem. And so we were able to identify some of the indicators from the degradation of these pesticides, but also underpin that with an awareness of some of the geochemical signatures of events that take place within that system, including fire and the sort of anthropogenic inputs from the agri-forestry activities. And so from a tall tale perspective, we produced some very, very nice tools to try to investigate the the situation, the health of the ecosystem, and to acknowledge the fact that if we don't harvest the cork, then the cork disappears, and that then being driven by a lack of demand from the cork stopper manufacture, that really was the result of a regulatory clash across cultural boundaries, where regulatory systems didn't work. And so you learned very, very quickly that despite being able to trace the pathway, that the political context is really quite an enormous challenge, and to resolve that wicked problem, if you like, takes more than the science to move forward. Second tall tale is one that's ongoing at the moment. We're working with a program across a range of disciplines to deal with antimicrobial manufacturing waste in the environment, and this is a UK funded joint UK India funded program to try to tackle the residues that are produced in the country manufacturing most of our pharmaceuticals, and that is very much a collaboration that has been very fruitful in terms of trying to map antimicrobial resistance in effluents, look at sensors to identify the key components and methods to treat and remove these substances from the waste to try to reduce the burden on the wider environment, and develop strategies to regulate that situation, and is part of a program of 5 big projects in the UK, India, AMR world. But I guess the sort of take-home message from this so far is not the geochemistry, not the technology, but the policy and the politics, which is the ultimate requirement for us to deal with this issue in society. And we've spent quite a bit of time as part of one of those work packages trying to look at who is important, and this is where it becomes a major challenge. If we look at the stakeholders in terms of pharmaceutical waste management, just focused in India, then these are the individual groups that we've been able to map that have influence on the effluent that generates the problem in the environment, and extremely diverse, very wide range of jurisdictions, both local, national and global, and so trying to work out how they come together in terms of their influence on the situation means that we need to adopt a protocol to try to evaluate their influence. And so this is a power interest grid analysis of these organizations, and essentially the landscape, the regulatory landscape that the environmental science then has to satisfy, then becomes incredibly complex, and gives us perhaps some of the explanation for why it's something that is a wicked problem. And I guess the sort of last tall tale I want to talk about, and where I think this is the only slide that I have a chemical element symbol on. Now that's quite a surprise in terms of an environmental geochemist trying to talk about environmental systems. And this is a project funded through UK Innovation Network. It's what's known as a knowledge transfer partnership, and this is a project that's looking at innovating in the management of waste electronic and electrical equipment in a small business. And this small business was set up to try to handle the recovered materials in a safe manner as a result of the implementation of the WEEE directive in the UK, and in particular focusing on hazardous waste coming from recovered electrical products such as TVs and monitors. So both the phosphors in the screens, but also the plastic that contains flame retardants. And this is delivered through the engagement of a highly motivated individual. Cecilia was taken on as the associate, and had the challenge to then identify persistent organic pollutants in these plastics, but in a way that the company could handle them in a way that the hazardous end of life waste classification was satisfied. And so what she was able to do was develop a handheld XRF protocol to allow these materials to be screened for bromine as an indicator of some of the flame retardant compounds, and also backed up by antimony, which is part of an activator in the flame retardant process. And as a result of that, the company was able to improve its performance in terms of profitability, but perhaps more importantly, gave it the capability to be able to screen out the non-hazardous components, because as you can imagine, that plastic is not just plastic, and different manufacturers manufacture things in different ways. So there is a lot of material that doesn't have flame retardants at significant levels that can be recycled, because the current state of play is that all the plastic is classified as hazardous and is incinerated. So a major sort of step forward, and that required her to deal with both this analytical measurement process, very much familiar with thing we're familiar with in environmental geochemistry, but also integrate that with regulatory constraints, and also help a company perform financially better. So just as a sort of a step back and reflect on those sort of tall tales and many others, in terms of the opportunities and challenges from the interdisciplinary landscape that we find ourselves in now and into the future. Some work that Alex and I did quite a while ago that pulled out some key points, both from understanding how participants in SEGH felt about meeting colleagues from new areas, and also some of the wider work that research funders have been doing to try to justify the move towards the perhaps new ways of addressing challenging problems. And so I guess the sort of top 5 areas in terms of questions that come as a result of conversations between different disciplines: creativity in terms of devices and opportunities that come from that conversation; language that you learn by discussing things with other scientific perspectives; and the whole sort of increase in focus on these interface areas means that researchers are being increasingly supported by both the sort of research infrastructure and their own organizations to engage in this activity, and that the quality of work can be enhanced because different perspectives are looking at it from their own needs and their own demands. So some great benefits that give us a chance to deal with some of these complex issues in a more tangible way. However, I guess the threats that do arise from this type of approach is that these conversations can slow you down if people don't understand your language, and often sometimes the enthusiastic response of a non-expert trying to understand your language means that you perhaps don't deal with the challenges as deeply as you should or could. There is always this question of credibility, both within your own organisation if you're involved in this type of activity, and also in externally. You know, what is he or she doing from this discipline and working in another? And again, the threats in terms of not being part of an engaged team. And that engaged team in terms of the commitment, if you don't really understand what's going on, then your engagement perhaps is not as strong, and you don't perhaps really get the perspective of the other members of the team. And finally, I guess from that perspective, there's always the risk that you know, enthusiastic novices will then adopt approaches that they perceived to be powerful from other disciplines, and I guess the term I sort of tried to coin was sort of building your own castle with other people's bricks. So you then have perhaps adopted the sort of learning outcomes from one particular area without being fully embedded in that discipline. And so really just to sort of finish off with a few thoughts on sort of canter through the landscape of interdisciplinary research. And what I wanted to do was get to the lopsided bit. And I wanted to get to the lopsided bit because it was one of the things that inspired me when I first became an academic in my institution, and that was coming across an individual who was a former principal of our institution, Lewis Fry Richardson, and his contribution to scientific life was the Richardson number. And the Richardson number is a number that indicates the degree of turbulence within a fluid system, and it was mainly applied in terms of mixing within the atmosphere, and the meteorological society have defined that here in general terms. I won't read out the formula, but it's a turbulence indicator. But he did more than that. He did more than anyone could have ever thought in terms of this application, and he verified it in terms of oceanography and mixing within ocean currents, and even stretched it to the prediction of the likelihood of conflict between countries based on the relationship of between them. Inspired Mandelbrot with the fractal indices, and a number of psychologists in terms of the numerical definitions of conditions, as well as mathematics, and obscured slightly at the bottom of the page is the banner at the top of our original building, which is Science and Art, and that is something that I think we can take as, if you like, the extreme range of the spectrum in terms of interdisciplinary interests. But I wanted I've got 2 minutes to cover something that I discovered in our archive of his lecture notes, and this was something that really brought home to me the opportunities and challenges that we have with our interdisciplinary environment. And these are a few words I lifted from some hand-scribbled notes in his introductory page to his lecture on advanced optics to physics students in the 1930s. And I won't read it through, but he talks about climbing the mountain of knowledge, looking across the landscape that's made of electrons, protons, and various quanta, and recognizing that you are excluded from questions of artistic value, of right and wrong, of politics, religion, and would remain, as far as merely scientists, profoundly ignorant. So we don't find these issues in the textbooks for physicists, and in some way these things are unreal, and the human concept is still a fact as much as the textbooks that we use to learn. And so the lopsided bit comes from his comment that a physicist is a specialist, like a specialist in other subjects, and has their own lopsided view of life. And we need to make sure that the community is supported by these specialists, and they pursue their specialist subject, but they are modest enough to learn about things in general. So I guess the sort of take-home message from me to emerging researchers is, can you see the bigger picture? Are you too lopsided? Think about how you question your research from perhaps a different perspective, or when you engage with the community, how you see the perspective they may have. Speak clearly, speak simply. Not talking about dumbing things down, but I'm talking about trying to clarify your position in a way that others can understand, and be confident to go on a journey into another subject and engage with the specialist there. Listen to the stories they have to tell, and hopefully tell your own tall tales. And remember, tall tales are the benefits, the impact and the contribution, and perhaps not so much focused on the limitations and the mistakes that you've made along the way. And so I'd like to finish and thank you for attending. Thank you for listening. I hope it perhaps gave a perspective of quite a random journey through that environmental landscape, and happy to answer any questions.
Andrew, thank you very much indeed. Interested to get to the lopsided bit at the end of it. A couple of things that, well, I was making notes quite substantially as you were going through there. There are plenty of things I could ask you questions about, but in the interest of fairness, I will absolutely completely open it up to the floor, but so that we don't all trample over each other to ask as rapidly as we can you put your hands up for me, please, if there's something that you would like to ask Andrew? No? Oh, yes. Okay. There was one. Thank you, Keith. Please fire away.
Yeah, Andrew, thanks for that talk. Very, very interesting. I liked how you touched on so many different aspects. My question to you was, what do you think we'll be talking about 20 years from now? What do you think are going to be the kind of key environmental health issues? And, bearing in mind that, 40 years ago, most of these issues weren't really even being discussed or really properly recognized.
I suppose it was my fault for having such an overarching title, but I guess water. Who's got the water? Where is it? Why haven't I got any? And where do I go to get some? And I think that's going to drive a lot of immediate impacts, and therefore our response. And again, it's this, the analogy of sitting on top of the train, putting the tracks in front of it as you're hurtling along. And I think that is still it's a major. It's with us now, and that will drive other things, food and sort of security of sort of migration and various things like that. So if we're still talking about it 40 years, well, it will be a really sad thing. AMR, as a geochemist talking about sort of biological response, you know, again, I don't speak the language, but I listen to the stories, and certainly coming together with the sort of stakeholder situation in India as we're doing at the moment, the sort of implementation of restrictions that have been thrown out by political lobby and pressure really scares me. We have, I guess, very little time to try to resolve how we deal with disease and infection in the future. And there's an the environmental contribution to that is really poorly understood, and I guess we'll hopefully see more work on that in the immediate future. But 40 years, 10 years, you should have asked me 10 years, because 40 years is a long time in this context.
Alex, fire away, please.
I think Alikos is first.
That's very kind of you to give away. I saw yours first, so Alikos, that's fine. Please do.
Andrew, thank you very much for a very challenging talk.
I don't like to do things easy.
Anyway, I agree with you that water is one of the main problems that we'll be having, not for the next 10 years, but from now on, unfortunately. And I don't think people are realizing that this is the biggest problem that we are having. And the next bigger problem is the soil fertility and crop production. This is the other thing that we have to tackle. I mean, we see now the war in Ukraine, that we have a lot of problems. Most of our countries have stopped the agricultural production, and we are depending on each other, which is not correct in my opinion. All of us, we have to return to the land that each nation has and start their sort of agricultural production. Otherwise, we are going to have problems in feeding our nations. And secondly, of course, I mean, agriculture needs water. That's the other problem. So really, these are the two things that we have to sort of really tackle in the next years.
Yeah, absolutely. And I guess, we had a tomato shortage in Britain
I know.
a month or two ago because we had the wrong weather in Morocco, so, it just goes to show you how short and immediate the supply chain is. And again, I agree with you, looking locally to get that resilience and on top of that, changing environmental conditions means that what you think you could do may change in terms of the capacity, in terms of disease and things like that.
And then we could start talking about virtual war. Should we be bringing tomatoes from Morocco as an out-of-season food in the middle of winter? But that's a whole different ball game and questions.
Absolutely, yeah.
Sorry, thank you for that question. Alex.
Thank you. The talk you've given, Andrew, it reminds me of some of the times we've spent together, obviously, but it encapsulated very much the reason I have enjoyed SEGH as a non-geochemist. And your point about AMR, antimicrobial resistance, reminds me further that the health community as a whole tends not to understand the need for environmental work of any sort, whether it's geochemistry or whatever. There's very little understanding, as you say, about the heavy metals and how they interact with microbial resistance, even to the extent, I believe, of stimulating the same genes, which is really quite intriguing. What does mercury pollution in the north of England mean to antimicrobial resistance in the communities that live off that bit of land? I don't know. And it's been a great struggle to get health people involved in SEGH. And I was just wondering if, with your contacts in India and China, if any of the wider health community there is interested in participating in the society.
Yep, certainly. I mean, I guess the other thing that I didn't take time to point out on the slide that introduced the India project is that Kiri Rogers is sitting in there, and Kiri, as a PhD student of mine, working on steel waste and then participating in SEGH, disappearing off to do a bit of work in industry and coming back as a postdoc on 2 projects on AMR, and then finally winning a lectureship with us, is perhaps, you know, a good example of how that sort of theme of nurturing people and addressing some of the key topics comes through. So I think, you know, we can use that type of progression as a well, I would say an exemplar, but I'm biased in that respect. And so that raises the topic, and I think the topic, you know, is such a deep one that we can, you know, we can find opportunities for the SEGH community to really participate. You know, I guess you're talking about exposures of organisms that we don't normally deal with. We talk about dusts and, you know, people eating metal contaminated or whatever foods and things like that, when we should be talking about the microorganisms being exposed over long periods of times and evolving in challenging landscapes, you know, in the soil or wastewater. So I think there, you know, in terms of marketing the topic to both SEGH and external health professionals, there's plenty of scope there to do that. It's just, if people see it as, you know, as urgent enough, it's the health services, I guess, that own the topic in policy, but it's the sort of environment that feeds it in terms of impact. You know, so.
And it may be that in terms of AMR, the veterinary health community might be more immediately accessible rather than the human health community.
Yeah.
But as you say, there's microbiology and all sorts of things there. Yeah, thank you.
Thank you, Alex. I'd like to add one thing in at this particular point, which was several slides back, which was talking about collaboration. And I think that's actually something, as Alex pointed out, we do really quite well, and has driven some quite novel insights to health and geochemistry. And you also talked about language, and a word that has become very much a standard word is bioengineering. And it's worth remembering that that's actually come from the biological fraternity collaborating with the engineers, and we wouldn't have some of the changes in physicality that move us forwards at this particular point had that not happened. And I think, you know, we can see the same thing happening for us too.
Yeah, absolutely. And I guess, you know, we have opportunities. We have the history and the tradition of who we are and what we've done, but that then allows us to contribute to these bigger questions. And, you know, so geological survey data, you know, robust, reliable, reproducible information about the environmental condition that then may be underpinning, you know, organismal development in those locations, you know, taking into account climate and other things. So I think, you know, that's Alikos, that's your next map.
Well, you sort of talk about something about food security. Last Monday, because I always shop my vegetables from the open market, there were vegetables from an area which is near the Lavrion area in the and I know the area very well.
I remember
And,
it. Yeah.
Of course, the problem is that we have documented everything, but people are importing, let's say, in the open market, food from that region, which is polluted, is contaminated. I mean, we know that for a fact, especially broadleaf vegetables and so on. So how do we stop this? This is the other problem. The quality of food that is on our table. That's another challenge in the future.
Yeah, absolutely.
Ali, because you still have your hand up, was there a question to come as well as that, or was that was that what you were about to comment on? No, that's okay. I wasn't asking you to put it down. It was just I was just making sure I hadn't missed something along the way. Excuse me. So, are there any further questions? I could keep this going for ages. The whole water thing I find absolutely fascinating, and I've been banging on about this for at the very least 30 years of water being a finite resource. And we can grow more food, but you can't make more water. And it worries me. And even back in the 1980s, I was using a video for teaching, which was looking about whether or not water would be the cause of the next war. That's a possibility, but this week I was absolutely shocked to realize that it's become a victim of war, that the Russians have actually drained the reservoir in Ukraine. So actually, when it becomes a weapon in its own right, then it's time to start worrying. But anyway, I don't really want to finish this one on a negative note. So how can I turn this one around? I'm going to go back to the very beginning of you talked about disasters and reality, and just the picture that you had up there was the disaster and reality eating the chilies with the chopsticks.
I was quite good, I must admit. I was okay at eating the getting the food in my mouth and surviving the sort of burn sensation, and after about a day or two in country, you get used to it and relish it and miss it sometimes.
Okay, so on that note, I'd like to say another big thank you to you again for taking time to put that together and to talk to us today. And we look forward to the next one, which is in about 5 weeks' time, I think, and is Jane Entwistle. So we look forward to Jane's talk on dust.
Yeah, I guess
so thank you very much indeed again.
In there then, yeah. Rather than the ramblings of a lopsided geochemist. Anyway.
There's nothing lopsided at all. That's fantastic. Thank you very much indeed, everybody.
Thank you.
Thank you.
Goodbye.
Thank you. Thank you. Bye. Bye.